Welcome to Study Loop.
So in this problem, we have been given an infinitely long straight wire, and at point P, perpendicular to this wire, the distance r is just 2 centimeters, which is now 2 centimeters. We are supposed to calculate the distance s at which the magnetic field at point P is maximum. So first we write down the vector r from this differential element ds, which is just ds. So if the current is flowing in this direction, if we take it as x or I, and this as j cap, sorry, this as j cap, then ds vector ds is just the ds times I cap, and vector r, if this is the center, if we assume that this point is the is our center of reference frame, then we can write this vector r as minus s I cap plus capital R j cap. So magnitude of the vector r is just square root of s squared plus r squared, and uh, the value of ds cross r cap is just r times ds, since we are just finding the magnitude, and I cap cross, so I cap cross I cap gives us 0, and I and j are perpendicular, so this just gives us r times ds. So using the equation, using equation 29.3, we can just write dB through equation 29.3, we can write dB as mu naught divided by 4 pi times I r ds divided by s square plus r square 3 by 2. Now, as you can see, this equation is maximum when s is just 0. So, which basically means that this length, this s, should be 0. Which basically means that magnetic field is maximized at point P when the current that is producing the magnetic field is directly below that point. So we have dP, so we have dP max as mu naught divided by 4 pi I r ds over r cube. So which basically gives us dP max as mu naught divided by 4 pi I times ds times r square. Now for part B, we are supposed to calculate. Uh, so for part B, we are supposed to calculate the value of S for which the magnetic field is 10% of the maximum magnetic field. So we just have 0.1 dB max. So this is trivial. We just substitute the value of dB, which is on the previous slide, divided by 4 pi I r ds over s square plus r square is to about 3 by 2, and dB max divided by 4 pi I times ds r square. So most of the things cancel out here. So we have IDS, and after doing some simple algebra, we find out that S is just 10 to the power 2 by 3 minus r. So if we plug in the value of r, which is 2 centimeters, which is 2 centimeters, we find out that the value of s, for which magnetic field is 10% of the maximum value of magnetic field, is 3.82 centimeters.